Hi folks, today I'm going to demonstrate a new trackball manipulator that I've been working on to handle whole earth databases much better. First I'll demonstrate the traditional trackball manipulator that we've been using in computer graphics the last 30 plus years. So the concept of a trackball manipulator is that you can interact with the camera position as if the actual scene in front of you is controlled by a ball. And so you can rotate left and right, up and down, and also around in a circle. And you can zoom in, zoom out, you can pan, and as you pan, as you rotate the scene, the actual axis that you pan on stays parallel to the plane of the actual monitor that you're working on. Now this combination has been used in lots of different graphics applications over the decades because it's pretty intuitive to work with. However, it's not perfect. So if we move on from a small model to a whole Earth database, which is in Earth-centered Earth fixed coordinate frames like this, tens of thousands of kilometers across in size, then if we start to interact with it, then we have problems. Now, we're using exactly the same trackball, in this case the center of the actual we're looking at, we're placed in the center of the Earth, and initially we can actually rotate it around just like a normal trackball, and actually it seems to be pretty intuitive. Things start breaking down though if we start to zoom into the model and trying to interact with actual elements on the surface, because the center is actually still the center of the Earth. It's not a point on the surface. So if we zoom in, so I'll try and find myself up to New York, and quite rapidly the actual scaling that would normally work really well for panning, which is moving relative to the actual distance from the actual center of you're looking at, that panning operation now is just really crude, because it's judging everything, it's measuring everything, scaling everything by the distance effectively to the center of the Earth, not the distance of the thing I'm actually wanting to look at. And it becomes very difficult to just kind of zoom into where you want. And if you did want to zoom in, you quite easily just punch through the Earth. If we kind of look somewhere else now, I'll try and look for Edinburgh, which is one of my home cities. And again, it's very difficult to control. So for a user who's wanting to use a whole Earth database, a standard trackball just isn't appropriate. So what I've been working on is a new trackball manipulator that takes the ellipsoid model of the globe and then adjusts the center and the look point and the behaviors to work as if you're working with like an Earth globe in physical space. And if you kind of think about having a globe in front of you and you put your finger on it, and you can then drag that finger around and spin it in different directions. So this is the panning operation. So rather than actually moving the whole Earth object around, we're actually just moving the eye point and the center point along the surface of the globe, and we always stay on the globe. Another advantage of actually having the center of you're looking at actually on the globe is it becomes much easier to zoom into areas. So we'll go into Edinburgh again this time. That's Glasgow, and Edinburgh is over here. There we go. So it becomes much easier to zoom into areas of interest. So there's Edinburgh Castle. And when I pan around, the panning is all done relative to how far I am away from the point of interest. And the actual movements are all relative to the current looking direction as well. So if I always pan, it doesn't matter whether I'm actually facing north or south, the movement of the mouse is matched by movements on the actual globe itself. So this is still a trackball, but we're adding constraints to the trackball to make it more intuitive. Another thing I'm experimenting with is the ability to actually hold the actual zoom position and have it just gradually zoom in rather than having to actually keep moving in and out like this. Again, this is all trying to make it more intuitive to working with these whole earth databases. The nice thing about the new camera manipulator, it becomes just so much easier to actually position the globe and zoom into the areas of interest. So here we're just jumping into New York, Manhattan, Central Park, all the way down to ground level. Another nice thing about the way that the camera manipulator is set up is that the projection matrix is being adjusted to the actual globe itself. So here we're actually, we're just a couple of meters above the ground, and the near plane and the far plane are actually kept within the actual space that we can see on the globe. But if we zoom out, so rather than being meters above the ground, we're now tens of thousands of meters, hundreds of thousands of meters, and then all the way out. With now the clipping planes are actually set up to actually encompass the globe rather than actually just that local space. But the way that it's done seamlessly, so you don't see any drops in the actual space. Thanks for watching. You'll better get the updates with the PagedLOD branch of vsgExamples.